Hello everyone, I'm Daniel. I'm a developer advocate for Teradata. Today, I will show you how to easily perform a customer segmentation with Teradata ClearScape Analytics Experience. ClearScape Analytics Experience also provides the best way for you to experience AI, machine learning, data, and multiple generative AI applications and use cases using Teradata Vantage. Follow me to it. We're going to start by visiting teradata.com/experience. Here you can create your very own account in ClearScape Analytics Experience. I already have one, so I will just directly log in. I log in. After you log in, you are going to see an interface that allows you to create database environments. These environments are full-fledged Teradata databases that you can use for any purpose that you would use a database or lakehouse. But in this case, we are going to explore the analytic capabilities of ClearScape through running the accompanying Jupyter notebooks. ClearScape Analytics Experience comes full loaded with several use cases that you can use to learn artificial intelligence and machine learning and working with data. We are going to focus right now on the K-means clustering environment, which is the one that is used for performing customer segmentation. What is K-means? K-means is, in very simple terms, an algorithm that allows to cluster similar data points together. These data points are clustered together according to how similar they are to each other regarding specific features or characteristics that they have. In order for this comparison to be performed, all of these features have to be numeric and they have to be on a similar scale. If you see the sample here, we have a plane, and if in a plane you have two scales that are totally different, for example, if this was in years and this was in seconds, you have not a valid comparison. So often you have to perform what we call feature engineering to reduce these characteristics of the data to a similar scale in which they can be compared. Also, usually you are not comparing only two dimensions because you have as many dimensions as features. So sometimes you have more than 3 dimensions, and that's difficult to visualize in our daily lives, but mathematically it's possible, and with Teradata is a breeze. To start with the example, we are going to load the sample data. For this, we need the password to our local environment. So this is the password that you use when you created your environment. I want to select the first columns of data that I have in the sample data set. And here we have the columns that we are working with. So we have retail data that obviously has an invoice number, some stuff code regarding to the products, the description, the quantity of products of that type included in that invoice, and the unit price. We have also the customer IDs, and this is important because we want to group these customers in different clusters according to features that are meaningful to us. And in this case, we're just going to assume that we want to group people according to their consumption patterns. So the quantity of products that they bought and the unit price paid are meaningful features to try to cluster them together. Now we are going to proceed to create what we call a test train split. We want to build our model, our clustering model, to group our customers together, but to do that, we need some data. But also, we want to have some data that we want to take apart to test how we are clustering the data together. So for that, we are going to take these customer IDs and we are going to separate that data into another view that we are going to use for pure testing purposes later. Now we go to the part of the feature engineering. So as mentioned, in this algorithm, we need all the data to be numeric in the same scale. To start with, we are going to create our training data. And for this, we're just going to create a view that includes all the data that we have, except the customer IDs that we define that we are going to use for testing. So we create that. Then we are going to perform some housekeeping, which is mostly related to management of outliers and null values. We are going to start with the outliers. This is very easy with Teradata. We have the outlier fit function, which will create a description of the mathematical or statistical dimensions of our data. And then we can use that table to perform a transformation to normalize those outliers to avoid a bias in our model. So we are going to do that. Also, we want to create some management of customer IDs that are null. And we have some of those. So we're going to assign for all customer IDs that are nulls, we are going to assign these 9,000 customer ID. And we are going to create a table with those. So that's another fit table that we are creating. All of these fit tables are basically descriptions of the data. We have not performed transformations yet. We can do that later in only one go. It's very convenient. Now, for this data that we have, we want to create extra features. For example, we want to know how much is the total sale value of a specific order. And for that, we need to multiply the quantity and the price. And this will give us an idea on how much a specific customer consumes. This is something that sometimes you will call the lifetime value of the customer. So we're calling it total sales here. Let's do it. And this is creating a description of the data. So it's just saying that we are going to have another column that's called total sales that will include the multiplication of total quantity by total price. It's just the description yet, not the transformation. Then we are going to perform a similar operation to create an average sales per item in a specific customer. So for this, we're going to apply another formula, which is total quantity times total price divided the number of total items. And this we are going to include in a column or feature that we're going to use the name sales per item. Let's create a fit table. Until now, we have not created any transformed data. We are just creating the fit tables or the descriptions of how we want the data to be transformed. So we're going to apply the column transformer, which is the transformation of everything in one go. And we're going to call it with the outlier fit table that we have. We have the simple input fit table that we have been using to manage the blanks customer IDs. And we have the nonlinear combined fit that we are using in both cases to create our total sales per customer and the average sales per item. We're going to create this table here. We have all our features, but remember, some of them are in different scales, specifically the total price and total sales and sales per item. Those are money. But total quantity and total items, those are just aggregations. We need to have them in a similar scale, and for that we are going to call another Teradata function, which is the scale fit. This function has several parameters that we can use. We can use the range parameter, which will normalize each of these quantities to a scale from 0 to 1. We are going to prepare the fit table, and this is giving us a statistical description of the data. And then we're going to perform the transformation, which is going to have all the data properly scaled in a scale of 0 to 1. So here it is. We have everything in a similar scale. We have our customer IDs. That is what we wanted. Each customer ID right now have a total quantity of items that the customer has bought, a total number of items that the customer has bought. We have the price. We have the total sales and the sales per item, and everything is nicely normalized. We can perform the clustering. The number of clusters in which we want to group our customers is a parameter that we have to define when we call the algorithm. You need to have knowledge of data science, but also of the business field to have a good idea on how many clusters you want to divide the data. You might have to iterate on that to see what makes sense for the business purpose. So we are going to call it in 5 clusters. We are going to allow our model to iterate on 500 times, and we are going to have a stop threshold of this amount that is basically the minimum distance that the model will try to reach out to stop the iterations. The training will end either when we reach the stop threshold or when we reach the maximum number of iterations. Here we have the table that it's given us the description of the data on the different clusters. So at the end, we have clusters 0 to 4, and we have the approximate dimensions of the centroids in the cluster 0. We are going to have data points that are similar to this amount in total price this, and so on and so forth. Let's go to select the model. This means how many data points are in each of the clusters, not perfectly balanced. The consumption patterns of your customers might be so that there are a lot of customers in a specific cluster, and that on itself is meaningful. We can build a chart with this information. So basically, this is just telling us whatever we saw here, that most of the customers are in the cluster 3. Now we are going to select the data that we have for testing. Remember all of those customers IDs that we had before, and we are going to use the same fit tables that we produced before to get the same features that we use for training to exist in our testing data set. This is just the testing data, so the data for those customer IDs that we decided to test on with the data properly scaled. Now that we have that, we can predict and evaluate the results. We can predict, that means that we are going to place these customers in clusters according to the model that we prepared with the training data, and we can check what is the output. This is the description of where these specific customers were placed in the clusters that we already had, and we can evaluate the prediction. So how similar is the result that we got of the testing data to the results that we got on the data in the training? So we're going to call the silhouette function, and if the number that the silhouette is given us is 1, that will be that the data was very appropriately clustered. If it's -1, it means that it was not properly clustered. And if it's 0, means that the data is on the border of two network clusters, so basically it's not meaningful at all. Let's see the result. And the testing data was clustered very nicely. The result that we got is very close to 1. So actually we have very good clusters for making our segmentation of customers. Remember that in a business context, basically what you will do then is try to find out what are the business properties of those clusters, right? Maybe you would want to focus your marketing or promotion efforts in a specific cluster. What is the meaning of this? It's a lot on the business person. The data person will provide the description that then is given meaning by the business user through other data points that might exist in the database. And that's the reason that having all of these inside of your data warehouse is key, because you can have a full view of what is going on with your data in the data warehouse or lakehouse. This is something that only Teradata gives you, and that's a very big advantage. I hope that you have enjoyed it as I did. See you in the next video.